All right, guys, so today I'm going to teach you how to run a repeated measures ANOVA in JASP. For the sake of this example, I have created this data set and a vignette to go with it. So let's say that our vignette is we have 30 patients seeking treatment for anxiety, and you want to test a new drug for anxiety. And there are 2 doses of this drug that you want to test. So one treatment will be administering 5 milligrams of the drug, and the second treatment will be administering 10 milligrams of the drug. And you want to have a third group as a waitlist control, so a group of people receiving no treatment to compare the treatment groups to. So you plan to measure their anxiety levels pre-treatment and after treatment with the Beck Anxiety Inventory, which is a scale that measures severity of general anxiety. So we have here a patient. You can ignore this. This column is just to tie these numbers together in Excel. So we're concerned we've got pre. These are our anxiety levels for the pre-treatment group, and post, which is those patients' anxiety levels after treatment. And then we have our 3 groups. The zeros correspond to waitlist control. 1 corresponds to treatment 1. Remember, that's the 5 milligrams. And 2 corresponds to treatment 2, the 10 milligrams. And so we want to run an ANOVA because we want to compare means. Remember, an ANOVA is comparing means of groups. Now, what's the difference between an ANOVA and a repeated measures ANOVA? So a repeated measures ANOVA is also known as a within subjects ANOVA. So if you're measuring the same group of people from one time period to another, you know you want to run a repeated measures ANOVA. So let's go up to the top here, ANOVA. You have this drop-down list, and we want to select repeated measures ANOVA. So the first thing we want to do is relabel this RM factor 1. Okay, and this is going to be time. So let's relabel this to time. And then level 1, our first level is pre-treatment. Okay, so we're going to rename this to pre, and level 2 to post. So then, now you see under repeated measure cells, these have been relabeled automatically to pre and post. So we want to move these variables from the box on the left over to their corresponding box on the right. So pre goes to pre, post goes to post, and our between subjects factors is group. So let's move group to between subjects factors. We are not dealing with covariates here. So now we have our output, okay? So within subjects effects, so within subjects, we've got time, okay? So is there a main effect of time? So we see time is here, and we look over at our p-value, and it is less than our alpha of 0.05. Remember, in psych, alpha is typically going to be 0.05. So if your p-value is less than 0.05, then you know you have a statistically significant effect here. So there is a main effect of time. Now, as far as sum of squares and mean square, we are not going into that in this class. As far as the F value, just know that the F value is basically a number that represents how much variability among the means of the data exceeds that is expected due to chance. But we're really concerned with this p-value right here. So now you have time and group. So this is the interaction. When you see a little star here, that's indicating that it's measuring an interaction. So the interaction between time and group. Again, let's go over here. We see our p-value less than 0.05. There is an interaction. There is an interaction between time and group on anxiety levels. Now we want to go down to between subjects effects because group is our between subjects factor. So we look at group. Let's go over here and we see our p-value less than 0.05. We are ignoring the residual line, okay? We are not dealing with the residual line in this class. You're just concerned time and group interaction, and group, okay? So because we have significance, now what we want to do, we want to run a post hoc test. Now the post hoc test is going to tell us exactly where we have those differences in means between our groups. So we want to move time over to the box on the right, group over to the box on the right. Now, typically, we use 2-key in this class. Sometimes JASP doesn't want to run 2-key, and so it will automatically have Bonferroni checked. That is fine, and that's why you see PBONF, that's P Bonferroni. And all that is telling us the differences between means and which exactly has statistical significance. So we see time, pre and post, P Bonferroni, less than 0.05. There is a significant difference between the means of pre and post. Now let's look at group. So remember, 0 is our waitlist control, 1 is treatment 1, that is 5 milligrams, 2 is treatment 2, that is our 10 milligram dose. So what this is telling you right here is we're looking at the waitlist compared to treatment 1. So 0, 1, let's go over here and look at P Bonferroni, less than 0.05. There is a significant difference between the means of 0 and 1. There is a significant difference between the means of our waitlist group and our treatment 1. We are not concerned with mean difference or standard error in this class, so we're really looking at that P Bonferroni. Now we want to see, okay, 0 and 2. So our waitlist group and treatment 2. Let's look. We have significance here, so there is a significant difference between the means of 0 and 2. So what is that telling us? That as far as the anxiety scores go, there is a significant difference in the mean anxiety score between the waitlist and both of our treatments. Now let's look between treatment 1 and treatment 2. And it also looks, we have a significant p-value here, so there is also a significant difference in the anxiety levels from our treatment 1 and treatment 2. So now what we want to do, let's see what this looks like visually. So let's make a plot. So let's go over here to descriptive plots, and let's put time on the horizontal axis and group on our separate lines. So your horizontal axis is your x-axis, which will be your independent variable, and time is always going to be on your horizontal axis. So let's scroll down to our output, and here we have our plot. Now, how do we interpret this? So we have time, pre-treatment, post-treatment, and then over here it's not labeled, but these are our anxiety levels, okay? And then we have group. So remember, 0, waitlist, 1, treatment 1, 5 milligrams, 2, treatment 2, 10 milligrams. So let's see what happened to these patients and their anxiety scores from pre-treatment to post-treatment. So before getting the drug or after getting the drug. Now our waitlist who did not receive any drug at all, looks like there wasn't much of a difference there. They stay the same, which is what we would expect because they're not receiving treatment. Now let's look at group 1 who received 5 milligrams of the drug. They did have a reduction in their anxiety scores, okay? But now we look at group 2 who had the higher dosage, and they really had a strong reduction in their anxiety scores. So what does that mean? How can we interpret that? It appears as if the drugs worked, but it looks like the higher doses of the drug, 10 milligrams, worked better than the lower dosage, which was 5 milligrams. Now, you may also be asked to generate a histogram and the means and standard deviations of this data. So what we want to do next is go to descriptives, okay? And then we want to select descriptive statistics. And we want to put pre, post, group under variables. We are not putting anything in split. Now let's go to plots and display distribution plots. Check that box. So here we have our descriptive statistics. This is telling us our means and standard deviations between the pre, post, and group variables. And now we have our histograms. So for group, this is typically not going to be anything significant. It's just a unimodal histogram, so that's not super interesting. But now we have our groups, post and pre. So pre-treatment, post-treatment, these are the anxiety scores, and the frequency of how many people scored these individual anxiety scores, okay? Now, what you're going to do is you're going to want to describe the shape of these histograms. So this one right here looks to be bimodal because we have a dip in the middle and some high frequencies on the outskirts of low and high. And this one is a skew, and this is going to be skewed left or a negative skew. Remember, we are concerned with the direction that the tail is facing. So now you have your complete output for your repeated measures ANOVA. We've got the ANOVA output, the post-hoc test, the plot, the descriptive statistics, and the histograms. So this is what you will need to run when you are running a repeated measures ANOVA. Thank you all for watching, and I will see you in the next video.